Now we're going to move from equations to inequalities. All right, so what's an inequality? Well, it's what it sounds like, so it's not equal. Okay, so everything we've looked at so far has been something like x equals 2. Well, now we're going to look where x doesn't necessarily equal 2, but it could be anything. Okay, so we've got these signs here, these little sideways V's. All right, well, we've got 4 options. Okay, we've got greater than and less than. Right, you always read left to right. So, for example, I could say x is greater than 2. That means all of the x's that are bigger than 2. All right, less than, I could say m is less than 15. All right, that's everything that's smaller than 15. So, for example, 10 would work, but so would -5. Okay, so because anything works, it's not equal. I'm kind of making a boundary now. All right, then we've got the same thing, but with lines underneath them. Okay, this means greater than or equal to, and less than or equal to. Right, so now if I'm saying that x is greater than or equal to 2, that means it could be 3, 4, 5, 6, 7, 8, and so on, or it could be 2. Right, so this is including 2. The first one is not including 2. Right, and then we've got less than or equal to. So if I said m was less than or equal to 15, it could be 10, -5, or 15. All right, so this or equal to includes the number that you're referring to. Okay, a couple other things that the way we separate these, all right, we're going to talk about graphing in a minute. And because we don't include the 2 or the 15, if it's just greater than or less than, we're going to use an open circle. All right, and because we include the 2 or the 15 or whatever number we're working with, we're going to use a closed circle. So we're coloring it in. So it's kind of like this one, we're coloring everything that we work with, so we're going to color it in, whereas up here we're going to leave it open. We're going to leave a hole there because we don't include it. Okay, and we'll use that in a second. So, graphing on a number line, we're going to use that open and closed circle. All right, a number line, you've seen them before. Oh, this is a crooked number line. Okay, I'm going to be using 2. That's what I'm referencing. All right, if I can, I usually like to put at least 0 in there. So there's 0, 1, 2, and maybe 3 and 4. We'll go 2 on either side. All right, I want to graph x is greater than 2. So I'm going to go to 2, right? And you can do this on your number line, but it gets kind of messy sometimes. So sometimes we do them above it just so you can kind of see. So I'm going to go right above 2. And because it's just greater than, I'm going to put an open circle. All right, because I'm not including the 2, but I am kind of setting a boundary there. Right, and I want all the x's that are greater than 2. Well, greater than 2 is going to be to the right. So I'm going to kind of shade to the right and put me an arrow. So this is graphing x is greater than 2 on a number line. All right, the reason that I can't just start at 3 and keep going is because 2.00000000001 is still greater than 2, and I got to include that. Okay, so there's an infinite number of numbers that get close to 2 without actually including 2. Okay, so to do x is less than or equal to 3, get my number line, we get 0, we'll do the same ones, 1, 2, 3, 4. Now you don't even have to put any of the numbers except for the one that you're working with if you wanted to. All right, and I'm going to put a closed circle because I'm including it because it's or equal to, and less than is going to be to the left. All right, so I'm going this way and put my arrow on it. Okay, if you notice, right, up here at x is greater than 2, it looks like it's pointing, right, to the right, and I shade to the right. For x is less than or equal to 3, I'm pointing to the left, and I shade to the left. As long as your variable is first, you can go by this rule, right? But your variable has to come first. It can't be 2 is less than x. It's going to be shading the wrong way. Solving inequalities, just like the equations we've been solving. Okay, we got to get the variable by itself by moving everything over to the other side. And then we do that by doing the opposite operation. Okay, the same exact thing holds true for inequalities. We're just going to kind of imagine that inequality being an equal sign and solve it like we have been. So x, excuse me, x minus 8 is greater than 3. So I want to get rid of the minus 8, so I'm going to add it. Whatever you do to one side, you have to do to the other. That cancels out my 8. So then x is greater than 11. Okay, we'll do a quick graph here. I'm just going to put 11 on it. Greater than means I use an open circle. And then greater than, I'm pointing to the right, so I'm going to shade, try to shade to the right. 7 plus x is less than 2. This is a positive 7. To get rid of that, I subtract it from both sides. That cancels, so I'm left with x is less than negative 5. Go to my number line, put my negative 5. I'm going to use an open circle again because it's just less than, and I'm going to shade to the left. I want everything that's less than 5. Alright, now these are just going to solve. We're not going to worry about graphing. They got a couple more steps into them. Okay, so I'm going to start with 3x minus 2 is less than or equal to 7. First thing I want to get rid of is this negative 2, so I'm going to add it. Whatever I do to one side, I have to do to the other. So I've got 3x less than or equal to 9. To get rid of the 3, I have to divide. So then I get x is less than or equal to 3. For 2x plus 1 is greater than or equal to 2x minus 3. I got x's on both sides, so I'm going to have to move them. Alright, so I'm just going to move this 2x on the right-hand side to the left-hand side. Okay, that cancels, and over here it cancels. So I'm left with 1 is greater than or equal to negative 3. Okay, so remember before, anytime that I canceled out my variables, I'm either going to have a true statement or a false statement. If it's true statement, that means all real numbers is my answer. If it's false, it means that I can't have it answer. There's no solution. Okay, so if we look at this, 1 is greater than or equal to negative 3. Right? Well, if we think about it, 1 is going to be greater than any negative number because it's bigger than 0. So this is a true statement. Right? So because this is a true statement, that means that all real numbers is my answer. So remember, you can write out all real numbers, or we can use our symbol, which is that fancy R with a double stem. And for the last one on this slide, I actually want to change it because I can already tell it's not what I was intending to do. So we're just going to change it to 21. If I can get this to right. 21 minus 4x is less than negative 4x plus 11. Alright, so again, I have variables on both sides, so I want to move them over. So if I take this negative 4x and add 4x to both sides, again, they're going to cancel. So if I bring down my positive 21 and my positive 11, now I got to look and see if it's true or false. So is 21 less than 11? No, it's bigger. Okay, so this one is a false statement, which means that it's no solution. No solution. And we have a symbol for that too, which is a 0 with a line through it. Okay, so either one of those will work. Okay, now pay attention whenever you're seeing if it's true or false. Right? If it is just less than or just greater than, it's kind of easy, but you don't want to get caught up. For example, if you had 3 less than or equal to 3. This would be a true statement because of that or equal to sign, because 3 is equal to 3. But if it were 3 is less than 3, that's a false statement, right? Because 3 cannot be less than 3 because it's equal. Okay, so keep up, pay attention to whether or not it's or equal to. All right, the only tricky part of inequalities, okay, it's very, very similar to solving equations, okay? You just move your variable, get them on the same side, and then isolate the variable by moving everything over, all right? But when you multiply or divide by a negative number, you must change the sign. Every single time, this is the easiest spot to mess up when you're working with inequalities, okay? If you multiply or divide by a negative number, you must change the sign. Okay, so for example, I got 7 minus x is less than 5. Okay, so first thing I gotta do is get rid of that 7. So if I subtract 7 from both sides, that cancels, and I'm left with negative x is less than negative 2. Okay, well, I don't have x by itself right now. I got a negative 1x is less than negative 2. So to get x by itself, I have to divide by negative 1. Right? And that's going to cancel out the negative, so then I get x, and I have a positive 2 on this side. Well, now I have to change my sign. So instead of it being less than, it's going to change to a greater than every single time. So it becomes x is greater than 2. So the only way this is going to work is if x is greater than 2. All right? Anytime you multiply or divide by a negative, you must change the sign. Other than that, it's just like our equations.